Hello. Now we are going to look at simultaneous equations and how we can incorporate word problems into this. So instead of just being straightforwardly given algebra or diagrams, we're going to be given a story, and we have to be able to find several equations from that, solve them simultaneously in order to get our answer. So let's jump into the question. There are 27 tickets sold for a play. Adult tickets cost €5 and children cost €2. Total ticket sales come to €75. Find the number of adults and children at the play. So what we have to do in this situation is try and see what equations we know. What stories can we tell based on what we've been told? Well, we know there are adult tickets and child tickets. Those are the only two groups that are described in the question. So if we know there are 27 tickets sold in total for the play, that means that if we add up the number of adults and the number of children, what we're asked to find, that must add up to 27. So that's one equation that we know. So let's call adults capital A and children little c. So the number of adults is going to be capital A, and the number of, cardinal number symbol, children is going to be C. So that's what my two letters mean. It's very important that we try and keep track of this, because we're going to have to be storytellers ourselves to keep track of the information that we've got. That's the challenge in these questions. So we know that if we add up the number of adults plus the number of children, that has to add up to 27 people in total, because 27 tickets got sold for the play. So that is an equation that we can write down. The second equation comes down to cost, and I know that because I'm given information about money. I'm given information about costs and money. So I know an adult ticket costs €5 and a child ticket costs €2, and I know in total we ended up with €75 from ticket sales. So if I added up, every adult ticket gets me €5. So every adult ticket gets me €5. So for every adult, I get €5. If I add that to every child, I get €2. And if I add both of them together, I have to get a total of €75. Again, I know that every adult ticket brings in €5. Every child that goes gets €2. And if I add those two totals up together, I have to get €75 for all of the money that got made. So every adult would give you €5. If I had one adult, I'd get €5. If I had two adults, I'd have €10. And so on. And so with the children. And when we add all of that money up together, we have to get 75. Now what we've got is two equations with two unknowns. So I know I can now do simultaneous equations. So I'm going to call this equation 1, and I'm going to call this equation 2 to better keep track of them. And now all I need to do is get one of my letters to sum to 0 when I add the two equations together. And thereby I am going to find out my number of adults and then my number of children. So I can see that if I multiplied my first equation by -2, I'd have -2c here and +2c here. Then when I added the equations together, I'd get 0c, and I'd end up with an equation only in A. Same method we usually use for this type of simultaneous equation. So I want 2 times equation 1, or -2 times, I should say, equation 1. And that is going to be -2 on A plus C is equal to -2 times 27. So we multiply both sides of that equation by -2. And we write equation 2 down just to keep track of it. 5a plus 2c is equal to 75. So then we have our -2 and we have -2a plus, sorry, my apologies, -2 by a is -2a, -2 by c is going to be -2c. So we have to multiply what is outside our bracket by each thing inside. And then that is equal to -54. And now we have equation 2. And when we add these two together now, we're going to end up with 0c. It's not very distinct. So when we add these two together now, we are going to end up with 0c, and we'll end up with an equation only involving a's. So we can add them together, and we get minus 2a plus 5a is 3a. There's no c's, they sum to 0. So minus 2c plus 2c is 0c. And we add them together and we get 21. 75 minus 54 is going to be 21. I now divide both sides by the coefficient of a. 3 divided by 3 is going to leave me with 1, so I'm left with 1a, so my number of adults is going to be 7. So I now know that there were 7 adults at my show, at my play. And I know that at the number of adults plus the number of children is 27. So I'm now going to use that, as we usually do with solving simultaneous equations. I now know one of my letters, and I sub back into one of my original equations. So 7 plus c is equal to 27. I want to get c by itself, so minus 7 from both sides. And I can see that there must have been 20 children at the show and 7 adults at the play, I should say. And that is what we need for our simultaneous equations with word problems. We develop the skill of being able to say, what smaller stories can I tell in the bigger block of information that I'm given? In this case, and it's a fairly common solution, I can talk about the numbers of people involved or the numbers of things involved, and then the costs of them as two separate equations, if I'm given information about numbers of things and costs of things. This is often a way that we would break up into two equations. And that's what we need for now.